Okay, so we're looking at an extension after the early stuff on integration. We're looking at areas under curves, and we're not going to use calculus for this first part, so we're using other methods. So if I've got a straight line, y equals 2x plus 1, and I want to find the area between 2 and 5, that's a sketch of what I'm looking at, and basically the question is, what shape is shaded, what is the formula, and then can you find the area? So think about that. What shape is shaded? Is there a formula? Yes, there is, and I want you to find the area. So could you pause the tape and have a go? Okay, so the shape that we formed is called a trapezium, and the formula for the area of a trapezium is h on 2 a plus b, where a and b are the parallel sides, and h is the height between the parallel sides, the perpendicular height between A and B. So, to find the height, I need those two numbers there. So when x is 2, 2 2s are 4 plus 1 is 5. When x is 5, 2 5s are 10 plus 1 is 11. So now 10 is 11. So area equals h on 2a plus b. The distance is that distance there, so that's 3 on 2, 5 plus 11, 3 on 2 times 16, 2 into 16 goes 8, 8 3 to 24, so the area is 24 units squared. Okay, copy that down and move to the next slide. Okay, but okay, still got the same shape, y equals 2x plus 1, between 2 and 5, but what if I can only use one rectangle? Okay, where could the rectangle go to give an approximate area, and what happens if I could use more than one rectangle? So, think about that, and when you're ready, have a listen. Okay, if we only got one rectangle, the rectangle could go there, okay, or the rectangle could go over the top. Okay, so there's two answers. There's a rectangle underneath and a rectangle underneath, over the top. So the rectangle, a lower rectangle, and there's an upper rectangle. But both of these answers are just approximations because the answer is actually a trapezium. So what happens if I could have more than one rectangle? Well, obviously we could, even if it's the lower ones, I could have a rectangle there, and then have another rectangle, and then another rectangle. So the more rectangles I add, the closer the answer would be to the real area. Okay, so that's that theory. Not too hard so far, so let's go to the next slide. So, if I'm using rectangles, there are two ways. There's left rectangles, where you join the left edge, okay, and you might join another left edge, and then you might have another left edge, and each time you have that, there's always space. So the left rectangle usually smaller than the real answer. Okay, but if we have the right rectangles, so we're going, so for instance, there, so the right rectangles usually larger answer. Okay, so copy that down and we'll have a look at some examples. Okay, so an example, find the area under y equals 0.2x squared plus 3 between x equals 1 and 3 using left rectangles of width 0.5. So I've drawn the shape, so the parabola is that shape, and between 1 and 3 is down here, and I'm going in 0.5 increments. So because I'm using the left rectangle, because the question said use left rectangles, I'm joining the lower side. So the first height will be when x is 1, the next one was when x is 1.5, then 2, then 2.5, and that'll be the answer. So what I want you to do is, doesn't matter if it's y or fx, but I want you to calculate the values, the y values for 0.2x squared plus 3 when x is 1, 1.5, 2, 2.5. And when you're ready, fill in the table and see how you're going. Okay, so I did when I did it, I got these values. I'm hoping these are okay as well. And so the area of a rectangle is length times width, and each of the widths is 0.5, but we're just going to have multiple rectangles, so we just add these numbers together. So that's my 4 rectangles, and when I calculate that, I get 7.35 units squared. So that would be the area under the curve using left rectangles. So finish, copy that down, and when you're ready, come to the next slide. Okay, so we've got another example, y equals x squared plus 1 between x is 2 and x equals 7. This time we're going to use right rectangles with a width of 1. Okay, so I've drawn in the rectangles, and the right rectangles means we're looking at the right hand side. I'll change colours. So right hand side, so this time the highest height is the 7 value, and I'm coming back in distances of 1, but I don't use the 2 because the last rectangle is at the 3 height, not the 2 height. So what I want you to do is calculate the y values, and then I want you to find the area. So have a go at that and come back when you're ready. Okay, so with y equals x squared plus 1, 3 gives us 10, 17, 26, 37, and 50. And the area of a rectangle is length times width, but this time each of them are 1, and then we just add those numbers together. And when you do that calculation, you get 140 units squared. Okay, so left rectangles, you look at the left hand side and you start from the lower number, and the right rectangles you go to the top number and come back, and you'll get practice on that. Okay, so we've done rectangles left, rectangles right, but the better answer is actually a trapezium, okay, because a trapezium fills in a lot more of the gaps. So for instance, in this particular one, I've got 5 trapeziums, and if I've broken them up underneath, so you can see the 5 trapeziums, and the beauty is the first trapezium's second height down this side is, so the first trapezium's second height is the second trapezium's first height, etc. So you don't have as many calculations. It doesn't look as bad when you actually have to do it, because a lot of the calculations are double ups. And we've got the area of the trapezium is h on 2a plus b. So copy that down and we'll see how it works on the next example. Okay, so for y equals x squared plus 1, we've had this one before. Use the trapezoidal method. Say that again. Trapezoidal method between x equals 1 and x equals 3 using widths of 0.5. So if you go back, so basically I've got 1, and then 1.5, 2, 0.0, 2.5, and 3. And so I've got, oh, it doesn't really matter what the shape is really. I'll just approximate, it doesn't really matter what the shape is. So these are the calculations we have to have but each time we get in these middle ones, we have to double it. It's only the first and last where you've got one edge. So the first thing we do is calculate the heights for y equals x squared plus 1. We're going from 1 to 3, and we're going up in 0.5s. So that's the calculation you have to do to start with. So can you pause, do some calculations, and then come back when you're ready? Okay, so these are the numbers. Some of them are whole numbers, but I'll just put extra decimal place in. So, area of trapezium is h on 2a plus b, but we've got lots of double ups. So our 0.5 on 2 is the distance between each of them. And so the first trapezium on the left-hand side is just using 1, 2. But then after that, the next 3 ones are going to have double ups. So we have 2 lots of 3.25, and then 2 lots of 5.0, and then 2 lots of 7.25. But when we get to the last one, there's only one of those, and that's it. So when you do that calculation on your calculator, you get 10.75 units squared. So that's about it now. So we've got left rectangles, right rectangles, and trapeziums. And there's the exercise from your textbook, 9D, page 418, and thanks for coming.